Hi, I'm Ben from Deliveroo. We are trying to be the definitive food company. So when you think food, we want you to think about us. We'll deliver you great tasting food to your door, to your home, to your office. We're a really fast-growing startup is a word you could use for it, but this year we've just been declared Deloitte's fastest growing tech startup in the UK for the second year running. So the growth curve is just phenomenal. And I wanted to talk about one of our primary engineering priorities, and that's how we just deploy code, create changes to our product. Every single day, you want to maximize the amount of time your engineers are creating changes, deploying to the internet, going to production. And that's the key. That applications are what make you money. The infrastructure layer is everything else that supports the applications. So if you maximize the number of people writing your applications, that's really how you make your money. And the goal of the platform is to let people just deploy code quickly and safely. And I'll talk about how we scale this process. So my team is about 7 people, I think 8 people as of this week. And we support a couple of hundred of engineers. And we have some techniques that we use to scale this process. Okay, so I'm going to talk about these points here. How we create new applications. We can go from an idea to the internet in a matter of hours, like a fresh idea. We can go from PR to production in minutes. We optimize for new people. We're a growing startup, so not everyone knows how the system works. So optimizing for new people means writing the documentation, creating templates, setting the conventions you need. The basics are really easy to pick up. And we design for scale. Growing quickly means that you try to reduce the friction it takes to just get your job done. Ultimately, CI means that humans get out of the way. You want the computers to do the checking for you. When you click the green merge button in GitHub, the pipeline should just take you the rest of the way there. So we separate application changes from the infrastructure they run on, isolating the work from one team to another. This lets our teams work independently of each other. They're not stepping on each other's toes. You reduce the need to synchronize between teams, and that's where that's where you can start getting bogged down in process. So you need to do whatever you need to do to scale this ability for hundreds of people operating your products. Let them make changes with autonomy, and we actually measure ourselves on this metric, this ability to make changes. So, for instance, our auto-scaling strategy is based on how many containers could we spin up, like that. How could we make the next change, and do we have enough capacity to do that? Wherever possible, avoid the need for people to interact with the platform and with each other. We have hundreds of servers. No one's going to log into a production server, run some bash scripts from the laptop. We try to keep the interaction at the human level to a minimum. We don't even give people credentials to the clusters. They don't need to know the secrets specifically. That's what the computers are for. In our case, developers build Docker containers. We run on ECS. We've actually only been using Docker for a little over a year. This is really useful for us because it means that we have a fairly greenfield way to deploy applications using a variety of languages and frameworks where we're quite polyglot at this moment. We support 4 main languages and frameworks, but from the platform point of view, I don't need to restrict the choices that developers use. If there's a good framework in a completely new language, we're a Rails shop, but if someone wants to spin up TensorFlow, which is a Python-based framework, then nothing that we build stops them or locks them into a particular way of thinking. I want to talk about creating new applications. How often do you create new applications? For us, we're spinning up a new service once or twice a week, sometimes even faster than that. We use infrastructure as code as a way to just declaratively create new applications as they come along, write a 4-line Terraform script, and you've got a new instance of a new application. Add a few more lines of Terraform, and there's your database. There's also a good talk that's going on in the session here. Amazon have got a new CDK, a Cloud Development Kit, come out, and that's more of infrastructure as code, but using an imperative style instead. We still use Terraform, which is a declarative way of creating infrastructure. We heavily rely on curated templates, and that's what my team is primarily responsible for, creating best practices, consistent way of spinning up tens of thousands of resources, both within Amazon and for third-party services as well. We can split these definitions across multiple teams. Whilst the templates are centrally managed and curated, we can give individual teams the domain, the responsibility to just spin up new web servers just for their own use cases. And that, again, can be independently managed in their own repo from other teams. With a template system, we can propagate good practices that you learn from your biggest application, your monoliths, and just stamp out the good operational practices everywhere else. So everyone wins and everyone gets to share knowledge. Changing applications is a higher frequency change. So what I call here is things like deploying new versions of code, changing environment variables, scaling up or down. These are changes that happen very frequently throughout the day, either automated through scripts or when humans make active decisions to turn on feature flags or change the configuration. Other changes that happen frequently throughout the day would also be database migrations. For that, we use a service called Hopper. We built it ourselves, and it lets everyone, it's a web UI that lets everyone see the current state of the system across all of our applications. Anyone can make changes to the system with a central interface. We can reduce conflicts. We can provide a high-level and audited orchestration of our production clusters. So there's a definition I need to make here, and what do we mean when I say an app? Specifically, an app for us is a code repository owned by a single team that we build into a Docker image. An application can contain multiple services, for instance, web services, background services. Our abstraction is on top of ECS, so that there's a one-to-one mapping between a Hopper service and an ECS service. Services can be scaled independently of each other. For instance, your background queues don't need to be scaled at the same level as your web workers. We also release services atomically together. So the same code will be either version 1 or version 2, but you won't have version 1, 2, and 3 at the same time. We'll also roll them back together if there are any issues. And one of the primary features with Hopper is automatic rollback if we detect any problems. Services for us share the same configuration. So an application is where the configuration lives. But that doesn't stop you from deploying multiple applications from the same code base, for instance, a monorepo with different configurations as well. This is a very good pattern for Go programs we're finding right now. This is how we create new applications. It's Terraform. You will learn absolutely nothing from just looking at that about how we build the platform underneath it. But there's some key things I should call out here. We use a module system where we just store our curated Terraform templates in S3. We can pass in constants that are global to that cluster. We actually treat this as React, but for infrastructure. It's props that you pass into all of your applications. And then after this, you can just have the specific details for your application. So in this case, the My App repository. And we'll create IAM credentials, Circle CI configuration, other build configurations that everyone receives. We set up ECR Docker image repositories. Everyone gets S3 buckets for configuration and secrets management. And also, we have a custom provider that registers the new application in Hopper itself. I'll talk about that in a bit more later. In this example, I'm setting up a new web service. So we will use our public web service template. This one will attach a public load balancer to the ECS service, create a placeholder task definition as well. It's just a simple web application that just returns 200 OKs. We'll set up the ALBs and the security groups appropriately, add in Route 53 for DNS service discovery, and that's all done just by declaring these lines. So a new team or a new person joining us can just copy and paste something like this, change the name of the application, and they inherit all of our best practices. Additional features that we do are really to just enhance the production runtime and serviceability of the service. For instance, you can tag off of Datadog alerts or ping off the Slack channels. You can include links to your playbooks or feature flags, and just attach ownership information. So when one of your many hundreds of services has a problem, you know immediately who to go to. We also expose this through Hopper, and you'll see that later in the UI. One thing I should also note here is that declaring applications in Terraform changes nothing immediately in the production system. Our defaults are to scale the service to 0. We don't enable auto-scaling. We don't enable auto-deploy. So just creating the Terraform itself is a no-op. Terraform doesn't track versions of code either. For that, we use Hopper. Hopper is our release management system. It manages the really high-frequency changes, the stuff that you don't need to write a PR for every single day. It's a central place to make changes. You can do it quickly and safely. Hopper itself can be thought of as a templating system for ECS task definitions. You write a quick template saying, I want this Docker image to run this command and listen on this port. And then Hopper will flesh out the more the cluster-specific information, the region it's in. It will update the current ECS deployment, do the rolling release. You can mix in with configuration from environment variables and just get a synchronized rollout of your application across all of those services and synchronized automatic rollback if anything goes wrong, you fail a health check, or you forgot to actually listen on the correct port. For the really generic kinds of problems that you can find, if you can write a health check for it, you can make it safe to deploy that application, even if you do make mistakes in your CI pipelines. Sorry for the ASCII art, I'm terrible at diagramming. But you get the idea. You write a pull request, it goes through your CI, your build system, and ends up as a Docker image somewhere. You mix that in with some configuration, environment variables, feature flags, pass it off to Hopper. Hopper hands it over to ECS, and then Docker takes over. We have a little custom, a little Go binary that we use as the entry point, called Hopper Runner. And this is where we linchpin all of our semantics, our conventions. It gives all of our application developers a consistent environment and a consistent way to interact with the platform. For us, it's one of the ways that we can defeat lock-in to a specific system. If we wanted to change to EKS later on, so long as we maintain the aspects that the Hopper Runner gives us inside the container, we can change out the implementation of the platform without making any application changes at all. And this is what Hopper looks like. It's an audited log of our recent releases. It'll show you what's currently in production. You get quick links to logs, service metrics. We've got buttons for rollback in case the automatic stuff didn't work, or retries if it's just a transient issue that blocks you. We've got links to all of the ownership information that you programmed in Terraform, Slack alerts, playbooks, documentation, even the code repositories. What's really nice about this system is that it can detect the common problems that you have when you're making a release. This is part of the safety aspect. It gives you helpful suggestions to remedy the issue. You can toggle auto-deploy off, fix the issue in another PR, whilst Hopper has rolled back to the known good version. And then when you're ready, roll out the new fixes and fix master branches again. All of our releases are versioned. Since your code is versioned, and therefore all of your Docker images have versions as well, we also version the environment, which is very useful for rollbacks. It means that you can have a very safe way of determining what is safe to be released, where are the bad configurations and where are the good ones, and always make sure that the live service itself is in a healthy state. We have a services tab in here where you can track the individual breakdown of the application, so the different workloads for the same code base. Services can include web services. It doesn't have to be a single web service. For some of our larger applications, we actually deploy multiple web services for them. You can then scale those web processes independently of each other. You can then isolate them to their database connections in other ways. Background workers, if you're reading off of queue, or it could be a metrics-based gatherer that then submits something to CloudWatch for auto-scaling. You can set auto-deployments or scaling here. We also now support auto-scaling, and a recent predictive autoscaler for EC2, if it ever comes to ECS, would also be very interesting for us. Imagine if you could just click a button and everything will be scaled appropriately. It's the dream. From the service dashboards, we link out to metrics where we can track ECS lifecycle of the containers whilst you roll out. You can see simple generic metrics like the Docker CPU or the RAM usage. If it's a web service, we'll get automatic ALB health rates and errors. Another trick that we also add to the service metrics is to just stick a number in about the AWS costs that an individual service will be using. It lets teams stay honest and not just scale themselves way too far. Hopper is also where you go to make application changes. You can make environment variable changes directly from the Hopper UI. We also have a Terraform provider, so you can create environment variables for your applications, but based off of other resources. For instance, RDS databases. We can generate a password for RDS, inject it into the application, and humans never need to know what the password is. It goes straight into the application. We support, we'll star out the actual credentials in UI just so that you don't accidentally expose them to humans. Hopper, for us, is also the place for one-off specific commands. We can do this for database migrations, data backfilling, simple debugging. What's really cool about this is because Hopper already knows the configuration and all the secrets for running the app normally. You can mix that in with extra IAM task roles and just run your database commands without having to pull out the secrets or interacting with any other secret stores that the application needs to in its lifetime. We also support lifecycle hooks, which are little commands that can be run at certain stages of the application lifecycle itself. For instance, Slack notifications to say that a deploy has successfully gone on, or did the release complete? Maybe it went into rollback and you need to notify your developers that, hey, by the way, you're not on the latest version, you've rolled back to a safe one, you might want to write some more code and fix the issues. We, as an engineering organization, like to solve problems using conventions. That's one of the only ways to scale out. All of our applications interact with the platform in the same way. This means that people can also be portable between teams as well, which is a really useful a feature of an engineering organization where you might need to quickly redeploy resources. Infrastructure itself can add seatbelts, a safety net, when you're creating new services. You'll always have new people in your teams. Not everyone will have the full domain knowledge. So if we can make as much of the platform safe to use as possible, that's really where we want to go to solve generic problems that everyone will have, such as logging, such as metrics, such as service discovery. Of course, that also means that if we're using conventions, any discrepancies, we can immediately highlight them, track the anomalous behavior, and fix those on an individual basis. On the application side, we also encourage a consistent way to write your applications. We don't declare specific frameworks that people have to use. That is a complete choice up to that individual team, and they have the full context and awareness over how to build their own applications, how to solve their own problems. That said, we do use conventional configuration files that most people can onboard onto easily. Circle CI configs for building. Hopper config is a template that we use for running. Florence is our feature flagging system. And again, all of your feature flags can just be kept with the repository that includes the code base. We can then draw them all in centrally and then give everyone a central UI for making those live configuration changes to a production system. Another convention that we have, along with READMEs, is playbooks as well. So, do you know what to do when that pager goes off? In the pager alert itself, it will link you over to our documentation website, and then from there, we can gather all of the playbooks for all of our other services, index them, and search them centrally on our internal documentation website. Super useful. And what is our documentation? We just went down the route of having an entire Git repository just full of Markdown. We render it with Gitbook. It's searchable. It's got playbooks in there, so you can actually, you don't have to have all of your documentation in a single location to write it, but it is rendered in a central place that everyone can find. From here, you can link off to your dashboards, your metrics. We can even link you off to Hopper itself, where you can then take further actions, like scaling a service up or just turning it off if it's being problematic. So that's compute and running applications. Other resources as well. So we have a curated set of templates for databases, caches, and queues. Lambda here is crossed out. We used to have a set template for Lambdas, but we've now realized that Lambdas can also, they're just another deployment artifact. Instead of using Docker containers, you can build zip files instead, give those to Hopper, and then Lambdas will get automatic rollbacks or audited release processes and configurations through Hopper itself. We maintain Terraform templates for Amazon services, but we also maintain a series of Terraform providers for third-party services as well. Kafka is a very good example of this, where we've taken the third-party provider from Confluent, and we've even submitted back our patches to some bugs that we found when using that. CDNs, Cloudflare, Fastly, and S3, they all have, you can all Terraform those up the same way. For instance, services that are just static assets where you don't need a dynamic backend, you don't need a service through Hopper, you just spin them up that way. So here's our databases. Here we go. I want a database. A little bit more complex than our applications, but it's the same idea. A curated template with all of our best practices in it, pass in our subnets, our security groups. Those go into the constants. They're the same for everyone, but they're specific to the deployment. So they'll change between production and staging, but they're constant for all the applications or all of our databases. We can add in references back to the applications that own the database. And we can even link the passwords, the secrets that an application needs to use the database directly from Terraform. And we can do that with our own custom provider to our Hopper itself. In Hopper, because we can make that relationship between an application's resources, such as its database and its compute, you can just link straight off into the service dashboards for the database as well, or the Redis queues, or any of the other related resources that an application can use. In an on-call situation, you don't want to be digging around big lists of dashboards or trying to hunt down the link. You can just find it straight from the application that's having the problem. Another good use of templating modules is the ability to just stamp out common good practices for everyone. For instance, with DynamoDB, you can create new tables easily enough. We don't even template the creation of DynamoDB tables itself. The provider is usually good enough for all of that. What we do template, however, is our auto-scaling strategy. We developed just a good way to just give a very simple, conservative auto-scaling strategy so that most DynamoDB tables will have enough provisioned throughput for them, set a minimum, set a target utilization, and that's all the algorithm needs to know. The implementation details are inside the module, and I don't need to expose that to everyone. We can just stamp it out across how many tables we use. Finally, I want to talk about actually going to production. standardization is the key here. We standardize everything as much as we can, including service readiness. Do you have known failures? Are they in the playbooks? Do you have monitoring in place? Are there links to all of your dashboards? All of your actions that you could take in an on-call situation, we'd like for them to be able to be done through Hopper. It's a central place that you can go to immediately and fix a problem in production. With ownership information in Hopper as well, we can also ensure that the correct team to make a call is there and that you know how to contact them. Most of all, it's important to remember that Hopper and all of the tooling, it's just a helper. It doesn't mean that you don't have to talk to each other. Tooling is there, it helps, but communication and keeping yourself fully aware of the context that your application and the way that it contributes to the overall ecosystem of the service, that's key, and that's how you scale out. So, thank you. I'm Ben. We also have an engineering blog if you want to learn more about how we build software and other software that we build. And so, thank you very much.
Well, I want to know, first of all, a round of applause for Ben. Thank you for giving us an insight. I want to know who asked the first question on this list, because that is phenomenal. Nobody? All right, first question. How do you guys just not eat all day, having access to all of these great restaurants?
I mean, we're a food company. We test our application very extensively. We eat all day, don't worry about it.
And what are the food perks at Deliveroo? I mean, what do you guys get as employees? I mean, this is also something I'm very interested in knowing.
Right. We have a product called Deliveroo Plus, which is just free delivery on all of your food. So you can just order from wherever you like. You don't have to bunch up your food delivery and just get from one place. Why? You could get the drink from one restaurant and a burger from somewhere else. We also, as a company, we just love food as well. I mean, it's a great place to just work and socialize over lunch. We have regular, we call them Hunger Games, where we'll just order a lot of food and just socialize as an entire company.
I've been in one of the offices during lunch hour, and I just love the community feel of it. Everyone puts their keyboards away. Everyone gets together in the main central area and eats together.
Our kitchen area is a significant chunk of our main office. It's just a big open area to just learn what other people in the company are up to, really.
And so you have a lot of engineers everywhere, and so Ross is wondering, is your team primarily based in the UK, distributed? What does that look like?
Right. We are a global team. Our engineering efforts are mostly in our headquarters in London, but we support remote work just fine. And there are people in my team who are 100% remote, and that's absolutely fine. There's no requirement to be in a single location.
What are some tips or tricks, recommendations for working with remote team members from your experience?
So all of the applications that we use to run the software, they're all web services. No one runs specific programs locally on their laptops. You don't have to make changes from a specific geographical location. You don't need to be in the office when you're debugging an application on the cloud. Right. There's just no need for it. So using just services.
And how do you onboard a new remote engineer within Deliveroo?
All of our material, again, wikis and meetings, they can all happen through web services. Onboarding new engineers, most of our engineering right now is UK-based, so it's usually just fine to get people in for the introductory weeks, meet the team, and that's fine.
Excellent. How much time does Hopper save your organization each, however you want to quantify, day, week, month?
Hopper means that we can just not think about the deployment process. Well, I have to think about it, my team has to think about it, but the other hundreds of engineers, they can just get on with their day, designing their applications, writing the code, creating PRs, merging them. we don't have to worry until there is a problem. Hopper gives us that safety net that an automatic rollback will bring us back into a good place. We don't have to follow all of the changes as they go out. There are just so many changes going out. Someone will turn on a feature flag, and that's completely not related to code, and that could break you. But the safety net that the system will try and keep you safe, that's the peace of mind that you win back with the system.
I might have missed this one piece, but how do you handle like data schema changes with an app? So you have to modify a table somewhere. How do you integrate that with Hopper? What does that deploy look like?
We have two ways to do that. If your development cycle has the capability and the safety nets in place, you can use a lifecycle hook. So the lifecycle hooks are super generic. They're not even webhooks. They are shell scripts that get spawned off inside your application code. So you can create just scripts, like in a programming language that fully Turing complete. You can create either Slack messages, but you can also just run database migrations or the checks for the database migrations automatically. We also support one-off tasks as well. So if you do know the command that you want to use to run a database migration, or if you want to roll it back, you can do that through Hopper. You just put the command into the text box in Hopper, and you get all of your logs, you get all of your auditing. You can see what time that happened in case you need to do some post-mortem analysis later on. It's all there.
That's awesome. And I'm going to jump to this third question because this is my next question. Is it open source? If yes, where's the GitHub link? And if no, why? Why show us this and then say you can't have it?
Right. Hopper is not currently open source. At the moment, it is just a Rails app. And by showing you this right now, I want to just talk about the principles that we use to design it. Some of the team are also here as well. And we do want to open source some aspects of Hopper. We probably won't release it as it is right now. What we can probably do is, over the past year, we've learned how to use the cloud more directly. So a lot of the functions that Hopper does, we can probably rewrite the entire thing as 4 or 5 lambdas, and then we'll open source those instead.
Will you go back to the slide where you had lambda crossed out and uncross it then?
No, because you could then use Hopper to deploy lambdas. Hopper also runs Hopper. So.
Next question is, does your team include operations or only release management?
All of our teams, including my team and all of our application teams, they are all dev and they are all ops. Everyone is responsible for the code that they write. That responsibility, that ownership is really the key. My team is responsible for the clusters, the load balancers. We are also driving the incident management process and our third-party vendors as well. So we can't just be pure ops or pure release management. That's not the way to get skin in the game.
And this is beautiful, but how long did it take to write Hopper?
Okay. We started this journey about 18 months ago. We had a proof of concept within a couple of months. And then from Hello World running on Hopper, we had our first production users this January. Now we're running our entire workload, hundreds of services in Hopper right now.
That's a great name for a product, too. I love it. Well, please, round of applause for Ben. Thank you for giving us some insight.